Hey everyone, welcome back to our APIGURU channel. For those of you who are new here, I'm Damien Tone here. On this channel we share everything you need to know about APIs. Today we will explore the best practices for designing a RESTful API. Let's get started. A RESTful API is a set of rules for building web services that communicate over HTTP using methods like GET, POST, POT, and DELETE. I will utilize the Dog API to share best practices for building RESTful APIs. An API like the Dog API can support numerous operations, and even more so when you factor in the relationships. Without a consistent and robust resource naming strategy, the API can quickly become disorganized and difficult to manage. In REST, the primary data representation is called a resource. Each resource is identified by a unique URI, which distinguishes it from all other resources. Establishing a consistent naming strategy for your REST resources is one of the best design decisions you can make for long-term success. Generally, you only need 2 base URLs per resource and 4 operation types. A resource can be categorized as a collection or an individual element. For instance, a collection represents a group of elements such as a collection of dogs, while an element refers to a specific dog. Let me give you an example. We can add a new dog to the list using the post method with the collection/dogs. When we use the get method on the same collection, we retrieve a complete list of dogs. The pot method allows us to update the list, while the delete method removes all dogs from the collection. When working with a specific element, the post method with /dog/id lets us add a new dog or return an error message if the dog already exists. The get method retrieves details about a specific dog. With the pot method, we can update that dog if it exists. If it doesn't, we can either add a new dog or return an error message. Finally, the delete method allows us to remove a specific dog from the list. This structure ensures clear and effective management of collections and individual elements within the Dog API. Here are examples of creating, updating, retrieving, and deleting an individual element using HTTP methods and the appropriate resource names. And here is an example of retrieving a collection representing a group of elements. Organizations often implement different strategies for naming REST resources. We recommend avoiding verbs when naming your resources and instead using plural nouns for clarity. Reserve verbs for actions that represent operations rather than resources such as calculate, convert, or translate. Be consistent across all APIs. Consistency across all your APIs is essential to ensure clarity and ease of use for developers. We recommend using concrete names for your resources such as /dogs. Let's discuss the response format. Organizations implement different strategies for requesting response formats. We recommend using the accept header in HTTP requests to allow clients to specify their preferred format. We also recommend using JSON as the default response format for clients who don't specify a preference. Ensure consistent error handling by returning errors in the requested format and documenting supported formats in your API documentation. Let's move on with pagination. Organizations use various pagination parameters. We recommend using offset and limit as the standard. Setting default values for these parameters is also a great practice, ensuring a smooth experience for developers when they don't provide specific inputs. This approach enhances usability and makes navigating through large datasets much easier. Next, let's discuss naming attributes. Organizations adopt different strategies, but we recommend using lower camel case for readability. This naming convention has the first word in lowercase, with each subsequent word starting with an uppercase letter, no spaces or underscores in between. Lower camel case enhances clarity and maintains a uniform coding style across your APIs. Now let's discuss error codes. Organizations use varying numbers of error codes, with some employing more while others using fewer. So what are the ultimate outcomes of errors and HTTP status codes? They generally fall into 3 categories. Everything worked as expected, the application encountered an issue, or the API encountered a problem. With this in mind, we can conclude that having 8 key status codes is sufficient. Alternatively, for a more streamlined approach, 3 key status codes can effectively cover most scenarios. Consistently using the same error codes across all your APIs enhances understanding and makes error handling more intuitive for developers. Organizations provide various error response content. We recommend including hints on resolving errors and a link for more information. This not only aids developers in troubleshooting, but also enhances the overall user experience by guiding them toward a solution. Next, let's discuss associations. Associations are used to represent relationships between entities. For example, you can model the relationship between dog owners and the dogs. Let's move on with complex variations. We recommend submitting filter criteria in the query string to retrieve a subset of a collection. Place variations after the question mark in the query string, like in this example. This approach allows for flexible and efficient filtering of results. Now let's discuss versioning. Organizations follow different versioning strategies. For clarity, we recommend placing the version name before the resource name. We also recommend maintaining support for at least one previous version to give developers enough time to transition before an old version is deprecated. Next, let's discuss partial responses. Organizations implement different strategies to request partial responses. We recommend using the field parameter with a comma-separated list of field names as its values to return a partial response effectively. This approach provides clarity and flexibility in the data returned. Let's move on with the search queries. We recommend using the verb search for global queries and queries across multiple objects, followed by a question mark and the letter Q as a shorthand for a query. The filter keywords should be separated with a plus sign. For search queries across several objects, it should be possible to specify the scope. Now let's speak about domain names. Organizations often use different names for the API gateway and the developer portal. We recommend using the subdomain API for the API gateway and the subdomain developer for the developer portal. This enhances clarity and makes it easier for users to navigate between the two. In addition, we recommend configuring the following web redirects. Users accessing the subdomain API should be redirected to the subdomain developers when using a browser. Additionally, users entering the subdomain's developer or dev should also be redirected to the developer's subdomain. Finally, organizations employ various protocols to authorize clients. We recommend using OAuth 2.0, which provides a secure and flexible framework for managing authorization effectively. Applying RESTful API design best practices is crucial for creating APIs that developers love. When APIs adhere to these principles, they become more intuitive, efficient, and user-friendly, essential for a positive developer experience. This drives API adoption, as developers are more likely to recommend and integrate APIs that are easy to use. Thanks for watching. If you enjoyed this video and want to see more, hit the subscribe button and turn on notifications so you don't miss any updates. Please give this video a thumbs up if you found it helpful and let me know what you think or if you have any questions in the comments. Look out for our next video in which we will review the risks of the top 10 API security threats and how to mitigate them.